Hey, are we live? Hey guys, we're back for the first time in a long time. Gosh, I don't know, how long has it been, Matt?
It's been I know it's been over 6 months because I think we only did one last year. Yeah,
And I don't know, I don't think I was there for that one because I know since I started at Brocade we haven't done one, and
yeah.
that will be a
It's been at
year
least
in
that long.
March, so that'll be a
Yeah.
year next month. So
Oh my God, it actually has been a year. It has been
yeah,
a year.
actually, whenever I told some people we were going to do another show with the Docker guys, I think they were like, "Wait, that still exists?" I was like, "Well, not really, but it was a good excuse to hang out with Madhu and Brent again." So
We're
what the hell?
we're about quality over quantity at the Class C block.
We're just about doing whatever the hell we want at the Class C block. It doesn't have to be quality. It doesn't have to be quantity. We're just going to do whatever we want.
You guys are
But,
so edgy.
well, yeah, I mean, Matt used to be goth. Anyway, so today we've got the esteemed members of the formerly known as Socketplane, which is now Docker Networking. They're basically the two people who are all of the brains behind it, right? Like, there's no more brains behind Socketplane than you two, I don't think, or at least Madhu. But we're going to talk about Docker networking today, and I would like to see a history of where it's been, where it's going, and kind of where we're at right now. And so, without further ado, actually, we should probably, Matt, you and I have both changed jobs, I think, since the last time we did and actually Brent and Madhu has also changed jobs since the last time we talked. So we should probably do a quick round of introductions and where we're at in life.
Yes.
So Matt, kick us off.
Yeah. So I am working on. I'm fully dedicated to software development now, which is a totally different change to where I was a year ago, or at least on the last show.
You do resemble that.
Well, most of my experience actually I channeled through the beard, which I actually recently cut off. So I feel like less of a developer now, but I'm hoping to get back in the game.
Was it a little bit like Samson in the Bible when he like cut his hair?
That's exactly right. That's like the perfect reference. Yes.
Nice.
How about you?
So yeah, I'm at Brocade now. I am a technical lead, which basically just means that I kind of assess technical things, make sure we're doing the right things, and also write plenty of code. So I'm at Brocade now, and that's been fun. And so Brent, Madhu, y'all, since the last time we talked, especially on the air, y'all got acquired by Docker, which was obviously y'all's focus. So Madhu, do you want to speak a little bit about that, like kind of that process and where y'all are at now and kind of what your role is inside of Docker?
Yeah, sure. Hey guys, I'm Madhu Venugopal, and my name is not on the bottom bar, so this is me. In fact, Matt, we spoke not 1 year back, I think 2 years back.
Mm-hmm.
In fact, we switched 2 jobs between our call before and now. So when we had the earlier podcast where Matt gave a lovely commentary about algorithm porn, where we were working for for Red Hat, myself and Brent.
Mm-hmm.
We were doing open daylight stuff, and then last year, not last year, it's been 2016 already. 2014, we switched to Socketplane, right? We started the company based on SDN for Docker, and early last year, Docker acquired us, and now from then on, we have been building networking solutions for Docker natively, right? That's where we are at. It's been a lot of fun. It's been a lot of learning for the past few years, really, and I do a lot of coding now more than ever before. So for Matt, that's where I am.
For everybody who doesn't know, I was joking with Madhu about him being in management and not writing code anymore now that he's at Docker. But so Brent, well, actually, Madhu, so what specifically is your role? You're the correct me if I'm wrong, but you're like kind of the lead developer, lead architect for networking for Docker, correct?
Fortunately, there are more smarter guys than me to lead the architecture side. So we have people like Jana, Alessandro, Santosh. They're part of the networking team, and the Docker engineers are all really, really smart. So I don't have the burden of leading the architecture, fortunately, right? But I lead the team. Yes, I lead the networking team, on the engineering side. But the architecture and design is all led by Jana and others in the team.
Awesome.
Yeah.
Awesome. So Brent, how about you? What are you doing inside of Docker?
Yeah, so I'm focusing on partners. So getting partners integrated. There's a massive ecosystem around Docker. Some of you guys are probably in networking and don't necessarily know what Docker is. So just a super quick overview. If you think about the history of compute, we started out with servers that ran an application on it. So one server, one bare metal server running an application. 10, 15 years ago, we started seeing what's called hardware virtualization or OS virtualization. So to try and find efficiencies, instead of having a server that's sitting there running at, with one application running at 3% utilization, the approach was to let's virtualize operating systems so that we actually use what we're buying. So we're not buying memory and compute that's sitting on the shelf. So virtualized operating system, now you've got lots of operating systems running on one bare metal server, and you can start pushing your capacity and actually use 90-95% of the hardware you purchased. So the next evolution that's occurring and has been occurring with Docker at the lead of that is virtualizing the application. So if you think to yourself, why are we running 20 operating systems in a single server with an application embedded in each one of those, when the value is actually the application? So the care and feeding of operating systems, the overhead of running lots of operating systems doesn't make as much sense. So you're not maximizing your resources. So what happens is there's basically a multiplier effect when you pull out that operating system. When you just run one operating system and virtualize the application, well, now you've got a multiplier. So where you used to run 20 VMs on a server, you can now, with 20 applications inside of each OS, you can run easily 100 applications on that same bare metal server.
Yeah, and that's actually one thing I would love to dive into today, because I know y'all recently had an announcement. Didn't y'all just recently make an acquisition in that area, Docker? And I'm curious kind of the networking implications of that, and kind of whenever we actually start compiling bootable apps, okay, well, how does networking fit into that, and how do we manage that? So that's a pretty interesting thing. We don't have to dive into that yet, but that's definitely a topic I want to hit on today. And we should probably dive in, because I know that we've got limited time for everybody today. So I wanted to make sure we covered everything from an intro perspective, and I guess let's just dive right in. So what is the state of Docker networking today, and kind of where are we at right now? And then maybe that'll lead into a conversation of kind of the compiled apps and where we think Docker networking, especially once we get into, and the name escapes me. What is that trend called? It's not a monokernel. What is it? Unikernel? Is that right?
Unikernel.
Unikernel.
Yeah, unikernel.
That's right.
Right.
So where unikernels are going and how we think networking I understand there's probably some things you can and can't say about that, but just curious, kind of a general technical discussion on where you think that's going. So we'll start off with, okay, where's Docker networking today? Where are we at? What's the state of it? What can we actually consume right now?
So Brent, should I take this one?
Yeah, buddy, please.
All right, sir. So a brief history in time, right? Let's see why we all like Docker, right? So Docker is like perfect for developers and ops, right? For simplicity, portability, and pluggability, right? Where an app can be written once and can run anywhere. Okay, so it's been perfect, and people have been trying it for a few years now. But networking was not in the same state till recently, right? So people are writing various wrappers around Docker in order to provide a networking solution, right? So that's exactly when we started Socketplane. Our idea was to actually provide a native way to provide networking, exactly the same problems that Docker solved for applications. We want to solve problems for distributed applications, right? It's exactly where our objective were. And Dial, after 1 year of acquisition, we are actually right there today, right? So what we provided for the past 1 year, the team has been working on bringing in simplicity to Docker networking, portability to Docker networking, and pluggability, right? So these three are basic tendency for Docker as a whole. and the same thing we are taking over in the networking as well. Okay, so on these three aspects, let's dive deeper a little bit on this. Simplicity in the sense that a developer who's developing an application need not worry about, hey, should I program this VXLAN tunnel there, or should I just have VLAN, MAC VLAN TEP, or is it going to be IP VLAN, or is it going to be NATing, or whatever it is, right? The application developer really doesn't care about that. And more importantly, the application that the developer is developing should just be portable across your laptop, to your cloud, to your data center, to your Raspberry Pi, so on and so forth, right? So that's the motivation that we have, right? Even within the cloud, talk about we have Amazon, Google, Microsoft, so on and so forth, right? So the same objective that Docker had, we try to bring it in networking as well, right? So that's the second aspect that we kind of solving with the existing one, and pluggability. So the pluggability aspect is what the ops really love, right? Where even though I like to claim that overlay is the best solution out there because you don't have to worry about anything, just it abstracts the underlay, but it does come with some kind of based on measurement that we had, measurement, it takes like 5% shaves off 5% performance because of the added VXLAN tunnel. Loss of physics, you cannot change that. So there are various options where operators can actually plug in their own plugins, right? For example, we have IP VLAN plugin, we have MAC VLAN plugin. Thanks to you guys, actually, you guys are all maintaining those plugins in the open, right? The GoFundMe project. So those plugins actually come to save the day, where operators can actually pick various solutions and plug it based on their requirements, right? Much similar to what the storage driver used to be there in Docker before, right? So the beautiful thing about all this is when an app is developed, it can be developed not specific to a particular driver, while the driver is not pertaining to a particular app, right? It's kind of mix and match. It works seamlessly. And on top of all this, manageability is very, very important. It's crucial, right? So maybe I talk a lot of features sounds like SDN, right? Because SDN talks about all this manageability, portability, pluggability, but that's a fact here, where it's application driven, it is portable, it is manageable, it is pluggable, right? And the manageability aspect as well, where we have plugins for IP address management, so on and so forth, right? So
let me put that in my own words real quick. So effectively, to the developer, you get a kind of a single library to develop your networking, the piece of your application that requires networking. You get a single kind of library that has a certain set of features or a certain set of methods or functions that you can call to do a thing. And then on the back end, that gets a driver gets utilized to actually port that action into whatever the driver is trying to do, whether that be an overlay, whether that be a standard, like you said, Mac and Mac or IP and IP. The driver actually handles, okay, they're trying to do this thing, and this is how I represent that thing. Is that accurate?
Oh, that's absolutely right. So there's one thing there where there are two kinds of developers. One we call app developers, right? Application developers who are writing programming where they manage the web servers, the backend databases, and apps that binds them together. Who actually writes the microservices applications to split them apart, right? Those application developers really don't care about networking even IP address level, right? All they care about is service discovery. Service discovery comes by default in Docker, right? So they don't really care about the layer that is taking care of all these abstractions, right? But there is an other layer of developers, right? Where, for example, let's talk about NFV kind of applications where they are network-centric applications where they want to actually drill deeper, provide performance, provide firewall-like applications, so on and so forth, right? So those kind of application developers, the developers are much more tuned towards what they really want at a bit level networking, right? So there are two kinds of developers, and we kind of cater to both of them, right? So for the real application developers who sits at layer 7, we provide service discovery, pluggability, and all those so on and so forth, which they don't have to worry about. And also from a network-centric view of a developer, they can actually develop plugins where they can actually make things work for their own benefit, right? So we kind of address both these requirements. Yes.
That's awesome because like usually you get one or the other, right? Like you either get something that's way too low level that people don't consume it, but like 4 or 5 people who really need that low level access will consume it, and then or you get really high level, and so it works for a broad set of people, but then the low level people can't use it, so they have to go reinvent something. So that's interesting and neat that the architecture allows for kind of both ends of that, where it's like we want to define new things that meet our specific business requirements, not necessarily things that have just been created for kind of the general purpose application.
Yeah, it's one of the most exciting things about Docker networking, in my opinion, is that pluggability. We've got tons of, about every network vendor in the industry is writing plugins for it. You've got, some of the more application focused, the Infobloxes of the world, that aren't necessarily concerned with packet forwarding, but they're much more interested in services and, IP addresses, which are still very relevant today.
So I'd like to interject here and ask maybe a different question with respect to Docker for networking people. So not just specific to Docker networking, but maybe Docker as an ecosystem, whether it's you're talking about Engine or the networking stuff that you guys have done, or Compose, or basically the ecosystem. How can network engineers of today, you used to working with traditional tooling that may or may not be the best, how can they leverage the Docker ecosystem to make their lives better? And is that something that we're going to see soon, or maybe a few years out?
So to be frank here, the journey that we began with, myself, Brent, and Dave, right? We were network engineers working on OpenDaylight for OpenStack, and we are drilling deeper into OVSDB, right? You guys know that, right? So the reason that we came into Docker is because Docker actually solved the problem that we are looking for, right? So the history again. When we were looking for a CA solution where we want to test our code across 15 different versions of OVS, because we read an OVSDB protocol, we want to work across various versions, right? So we looked at various in fact we spoke to the Linux Foundation people to have spin like 15 different VMs and manage it for us. They said, go to hell. We can't be having different VMs for individual things, which is very hard, right? So we were looking for a solution, and Dave said, hey, Madhu, do you know we something called Docker? It's very interesting. Can you figure it out, right? Then we worked on it, and we found it so unbelievably awesome, where you can actually run the OVS user space inside a container, right? And since kernel is the base thing, where you use the same kernel, and we are able to spin 25 different versions of OVS in parallel, able to test them end to end, right? That was kind of unbelievable. That's kind of that actually switched the entire gear for us, right? Where Docker makes something possible which was never possible before, which is definitely possible before, where it is so cumbersome, where nobody were able to do that with the Docker as a platform. Even engineers like network engineer like me can make use of it like tremendously, right? Now, if you look at another way of looking at it, now people are doing Dockerizing, containerizing the network tools now, right? All the Linux tools that you really want for debugging your application have been Dockerized now. Meaning, you just say Docker run tool debug this one. That as an engineer, you can write the tool for actually debugging the end-to-end solution, and anybody in the world can use anywhere, right? That's kind of, again, something different paradigm for all of us, because none of us were used to it before. Now the paradigm is shifting completely, right? A few examples. Brent,
Yeah, and it's funny. Like one of the things that really made this click for me when I was first exploring the idea of running Docker, like on a network switch, for instance, was this was, I can't remember how long ago this was. This might have been over a year ago. Basically, tossing around these ideas with somebody that worked for a vendor that was thinking about doing this, and it really started to click with me when I realized that this isn't really something. We don't need this kind of tooling to do like really complicated, grandiose stuff. It's not one of those things where like, oh, I need Docker on my switch so that I can like load in my own custom routing engine, or something weird like that. What really made it click for me was just a simple matter of saying, and I think actually, Brent, you might have said this recently as well on Yvonne's podcast, where it's it's super useful to just simply say, like for instance, the ping tool that comes with Cisco switches by default. It's kind of crappy, and it's really simple. This isn't like a sexy, like revolutionary idea, but like, wouldn't it be great if we could just use our own ping? And having Docker on the switch enables that kind of thing. It's not really a groundbreaking idea, but it's very useful and it's very ops friendly. That's, I think, one of the coolest things for me, at least for getting people involved with this kind of stuff. Just those really simple use cases.
Yeah, no, oh, sorry, go ahead.
Go on, Brent. I'll reserve it myself. I'll keep it in my mind. So.
Okay. Well, so you're really hitting it on the head, in my opinion, because so a lot of networking, especially ops, they hear developer and they tune out, and rightfully so, because today, how practical is that? Right? If you're not working at a hyperscale, then there's a question on practicality and how much is that going to help you today.
What I've found is it's kind of like that's great, but I've got X list of responsibilities, and nowhere in there is there any time for me to do any of the things you're saying. So
yes,
right,
I appreciate that, but come back and see me in like 12 years.
Right. Well, you don't have to go be a developer. I think the key is to move into DevOps. Which I would argue the networking industry is trending towards a DevOps model. Right. Automation is incredibly important. What Docker does with packaging enables that. So I think a couple weeks ago, Arista announced Docker running on the switch. There'll be lots more announcements. That example, I'm actually going to pop in a URL into my tag here that's got, no, it didn't go into there. If you go to github/gopher-net, we've got some good examples of.
We'll put it in the show notes too. Just email us a URL. It'll be in the link underneath this video.
Awesome. Because I love that. I mean, NetOps doesn't need to be managing operating systems, right? I mean, we've all had, if you've ever been in NetOps, you've probably requested a VM and you forgot the VM's there, and so now there's a VM orphaned, either locally or somewhere in the cloud, and you're paying for it. You should just be able to run the application and have it exit. So bringing that to your network nodes, like it's as easy as you should be able to run iPerf from one end of your network to the other end of your network and not have a proprietary tool in order to measure. So I think there's a clear path of getting your arms around management by using the existing open source. It's a read-only thing, so you're not going to wreck your network doing it, and then start moving your way down into actually a rewrite where you're going to change configurations or you're going to react to some kind of event that happens in your network. I definitely think that's kind of the future.
So,
I hope you get the message out there, because I know that the main use case that people always like to talk about with Docker is for developers, and so I would imagine it's kind of like fighting an uphill battle, for you guys specifically trying to get the message out for operations folks, fighting against essentially that primary use case that tends to dominate all the media attention and things of that nature.
And to level set for our users real quick, Docker was really ambiguous for me until I used it the first time, and then once I used it the first time, I was like, oh, well, that's amazing. That makes sense. It seems like this kind of nebulous thing, but all Docker is, if you think about it, like whenever you run a process in Linux, it runs, it gives you a PID, it's running in some kind of memory space as the user that's running it. Docker is effectively doing the same thing, except virtualizing all of the stack of the OS except for the kernel. And so, like, literally, whenever you look at Docker PS, which is actually a command, it shows you all of the processes that are currently running for Docker. And it's literally one Docker container per one application running. It doesn't have to be technically, but that's typically how it's used. And so you say, I want to run my app. Hey, container, go run this command, and as soon as that command exit, that Docker container goes away. So to level set for people who don't understand what Docker is and it's this nebulous thing, that's about as layman's terms as I can get it. And I would also encourage you to just download it and run pwd in it, and then you'll understand how it works.
Right. I just want to add one thing before I forget this one, right, where the brain turned bad. What you guys brought up, I want to make sure that I add one more color to that, right? So the compute world has actually made use of the operating system extensively, right? The kernel features really extensively, and then that made it very, very solid. It helps both ways, right? Where the operating system became very solid, the kernel became very solid, and the application on top is not reinventing the wheel. They just make use of the kernel and then adding value adds on top, right? Linux kernel has so many quality networking features, so many of them, right? And we in the networking field, right? I mean, especially since because of various vendors, they write so much custom software. We have kind of not seen the development that has happened on the Linux side. Linux networking is so powerful, so much valuable tools are out there, which we missed for so long, right? Companies like Cumulus, they came along, figured out, hey, you know what, Cumulus and Arista, they figured out, hey, kernel itself is a great tool for us to make use of, right? Now, just think about Docker. Docker is actually democratizing that particular aspect as well. So the entire Docker networking today is implemented based on Linux kernel's features. Seriously, right? And Linux kernel is implemented with a specific set of, hey, you know what, we don't want to put a monolith, big monolith. Linux kernel is built for a tool at a specific thing, right? So it was difficult for network engineers to go and figure each single tool. We understand that. But Docker now is democratizing that. We are writing a awesome user space application which makes use of these kernel features extensively. So now, if you look at the VXLAN that we have, overlay networking is entirely based on Linux kernel, not even OVS. OVS is awesome, but we are using the Linux kernel VXLAN completely. We are doing IPVLAN, we are doing Mac VLAN, we are doing everything that you see, masquerading, we see, contractor, so on and so forth, right? It's there in Linux kernel for such a long time, and we never exploited now, right? And Docker now we are able to make use of it completely end to end. And when the network engineers start seeing that, I'm telling you, right, all the proprietary software will just give way for Linux software, really. So yeah.
It's an interesting take. There has been quite a bunch. There's been a lot of movement on that front for quite some time now, and I feel like it's kind of starting to hit critical mass now. And so I think as the years continue to go by, I think we'll only see more and more of that. And so it's interesting how the concepts that started kind of as in server management and server, because there's naturally more touch points to servers than there are networking. But there's a lot of kind of intangibles that came along with that, like taking the human element out of managing those systems. And so that trend we obviously know has been moving towards networking, and that will only continue because there's so many benefits to managing systems in that way and managing known systems with known APIs in that way that I can't imagine that won't continue to just trend up into the point where all of that has kind of reached a critical mass and you're managing the things through similar interfaces, just like you were describing, where it's like you want to get this thing accomplished, you can remove the human element and you can do it through a kind of seamless way against these different things.
Yep.
So let's switch. I want to switch now because we only have about 15 minutes left. I want to switch back to the topic of kind of the future and unikernels and where Docker networking fits in there and where networking in general fits in there. Because if you view a server as this asset that just runs applications, then yet there's still some semblance of a driver, there's still a Linux kernel running there. And it's very stripped down, but it still has to have a networking stack. It still has to have an IP address. It still has to have packets that leave it and go to some sort of host and then hit a physical network. So let's make that whole process a little bit less ambiguous for our audience and myself. And let's talk about where you think Docker networking fits into that and kind of how you see that progressing. Because there's an opportunity as things trends toward that to actually simplify the kind of complexity that's been going on, especially as apps, because the apps that get written for unikernels will naturally be built in an architecture that appreciates things like not needing layer 2 adjacency and stuff like that. So I'm curious kind of where you see things going. And I also am curious is with Docker right now, do you see applications actually honoring the fact that they don't need things like layer 2 adjacency, or is it kind of like sometimes people still shoehorn in an old enterprise JVM that's running in Docker? So I'll leave the floor to you guys, to Brent and Madhu, to answer that.
Okay. Brent, me, who want to take this one? Should I take this?
Yeah, go for it, please.
All right, I'll start. You can pitch in, right?
Okay.
So, I mean, when you ask this question, my mind is racing all the places my imagination can go, but I need to curtail it for 15 minutes talk here, right?
Sure. Sure.
So think about Docker, right? When somebody says container, we should not realize container as Linux containers. Container is a concept, right? Is to contain, package an application and be portable. That's where the abstraction is, right? Now, Linux containers were the first implementation of that. LXC, if you know, LXC was the first implementation of it. Now LXC has been deprecated in 1.10 actually. Now we use libcontainer. Libcontainer is a way for us to do the Linux container thing, right? In parallel, we are now Microsoft is we have Docker daemon and client with Microsoft applications now, right? Meaning it's not just for Linux containers. It's containers is portable not just on Linux platform. It's across the platforms and operating systems, right? It's already there, right? And there are various examples that you see out there in the wild where containers are not just sharing the same kernel. Unikernel is one example where we are trying to Docker's vision is to program the internet, right? It's not to program a Linux platform. It's not to program a Windows platform. It's not to program unikernels. It's to program the internet, really, right? An application should be ideally portable from your car's audio system to your cell phone system, right? So it should be able to pervade everywhere that you can possibly go into. That's the power of Docker containers, right? So if you look at from that perspective.
But to be clear, though, right now, I can't take a Linux Docker container and then go run it on a Windows Docker container, because unless I can, and that's news to me. But like right now, if I build a container for a Linux platform, I can't go run it on Windows. Now, obviously, that would be the obvious trajectory of a future goal, but right now, I can't port those things between the two, correct?
Right. Right now, it's not possible, of course, right? But think about it, right? I'm talking about the vision here. I'm talking about a vision where how this is trending towards, right? It's trending towards the thing where it should be programming the internet completely, irrespective of what device, right? What platform, which infrastructure, really doesn't matter, right? And developers should be able to program, and that's where it should stop, right? When it comes to IoT, it can run anywhere. It should be able to run anywhere, ideally, right? So if you think in those terms, right? The constraints that we have already, let's take networking as a small example here, right? In networking alone, think about it, you should be able to an application and run anywhere. And we keep saying that one size don't fit all. Of course, it doesn't fit all. So we should be able to run in overlay mode or in VXLAN mode, so on and so forth, right? Now imagine an entire application stack, right? Where networking is just one piece of it. Now we talk about various different aspects, security, like database servers, so on and so forth, right? Now, an application developer should not be concerned about how and where is deployed and which various check marks that the CIOs must tick off before we able to deploy that particular thing, right? So application should be able to deploy, write it in the way they want to write it. Now, let's come to unikernels as an example, right? Unikernels, as I understand, right? It's still early for me, right? It fits the bill right between the virtualization that we saw in hypervisor and the packaging that we saw in container, right? The unikernels provide the absolute security that you love in a virtual machine kind of an abstraction, but provides the simplicity and the portability like what container provides, right? Yes, it's a long way ahead because we need to still write the build system is a bit complicated, but that's what Docker is good at. Docker is not just about running the containers, it's also about packaging it very, very well, where developers don't care about how it is packaged. It's all done, taken care of for you.
Yeah, because Docker in its inception actually utilized some of the kernel tools to do containers. And then obviously they moved away from that. But what their key was, at least at the inception of Docker, was let's make the stuff actually consumable to the average person who doesn't have to be a kernel developer to figure out how to do this stuff.
Exactly. So in fact, 10 years back, I myself have done something with LXCs, right? It was too hard. I mean, even for an engineer like me who used to code like 25 hours a day, right? Sure. It was too hard for me to even fathom this complexity and then put them together, right?
Sure.
Now think about application developers who actually have life, who want to spend time with their family and not just keep coding and hacking and debugging issues, right? This is a boon, really, right? Now, just if you throw a unikernel at them, they're just going to just gasp and say, what is going on, right?
Yeah, because I mean, I'm assuming the way that, like most things start, I'm assuming right now, like you said, the build process is a pain. I'm assuming it's pretty much similar to a build process of trying to like cross compile something for PowerPC and you're on x86 and you have to build a whole tool chain out just to build this one app. And so just to get the friggin' application running is kind of a process. So Docker makes an acquisition, is going to do the same thing that they've always done, make it super easy for people to consume that.
Exactly, right? So once we make that happen, then imagine about operators. Operators will say, oh, lovely, man. Now I have the flexibility between, hey, you know what, my ops team strictly wants to deploy it only in a VM environment. Sure. Somebody will say, you know what, no, I want to deploy it in a unikernel where, as Brent said, right, unikernels, of course, will be much more resource effective than a VM, right? It gives the right balance between them, right? But if it is a CI kind of system where they don't care about that, they can just run Linux containers natively in the Linux kernel, sharing the kernel, right? So now we have various levels of abstractions where developers don't have to care about this abstraction, but operators can actually love it and then deploy it the way they see fit for their own deployment needs, actually, right?
And I think it's interesting too to go back to what Brent said initially. Like all that we're trying to do, it's all about the applications. Networking doesn't exist to pass packets for nothing. Like the application is king, and what do you run an application on? You run it on compute resources. And so all of this is ultimately trying to get to, you've got a finite amount of resource that you can run applications on. How do we best utilize that? And all of these things are taking us closer and closer to the point where we can utilize, like Brent said, 90, 95% or even more of the hardware that we have.
All right, cool. Just want to interject here, and as we start to wrap up, I want to ask both Madhu and Brent. First off, how can we keep track of the work that you guys are doing? And also, do you have any upcoming events that you'd like to plug for the audience?
Brent, take it up, guys.
All right, buddy. Yeah, so one thing coming up pretty soon, so we've got the Open Networking Summit that's now run by the Linux Foundation. John Willis, who's not on, couldn't make it today, but he's one of our cohorts. We've got a cool DevOps Days for Networking set up. A couple of you guys will probably be there speaking. We've got, Anish Sheikh from Google. We have Dave Cohen from Intel. We've got some really awesome guys that are going to be there. So love to have you all come out. It's going to be March 14th at the same place that ONS is at out in the Valley. Other than that, find me at Network Static. I'll be doing some blogging over the weekend on some of the killer features that we've got coming out. And yeah.
Nice. Thanks, Brent. And I'll also plug for you the GopherNet organization that you're running on GitHub, or but that you're participating in. It's a great collection of really useful tooling, and a lot of the plugin work that you're doing is actually located there. So it's a really cool area to check out. Madhu, how about you?
Well, I mean, as I said, I code all the time, right? And so if you want to reach me, GitHub is the place to reach me, right? We're on GitHub. Mavianago is my handle there. And thanks to Brent, I started tweeting as well. Well, I feel like old, but yeah, I am tweeting now, receiving tweets, and Madhu Venugopal. Yeah, I mean, reach me wherever. If you have any questions on Docker networking, on networking in general, awesome to catch up with you guys. And you know what? 110 was released yesterday, so I still have the hangover of the release. It's an awesome release. Try it out. It's really good. Any feature, if you want to see what is coming along, follow the GitHub channel. If you just follow the Docker Twitter channel, you'll get all the new features coming along and what we are up to. So, and there's a project called libnetwork. That's where the networking code for the Docker goes in. So participate there, contribute. It'll be awesome there.
Thanks, Madhu, and thanks, Brent. Thanks to both of you for joining. It's been a pleasure. I know Matt and I both enjoy always talking to you guys with whatever you're working on. So since we've set this breakneck pace for ourselves, normally when podcasts sign off, the one host asks the other host, like, what are you going to be doing, for the next week or so? But in our case, Matt, what are you going to be doing for the next year or so?
Good. That's a good question. So I focus on automation integration at Brocade, and so you can, in 2016, expect to see a lot coming out about what Brocade's doing in the automation space, what we're doing with basically a lot of the things that we talked about today, pertaining to Docker and not, just like things about how we can make the network engineer his life easier, take out some of the human error elements, and allow them to be freed up to do kind of the important parts of their job, which is planning and actually making sure that their networks are designed correctly for what they're trying to accomplish. So that's the space I'm focusing on. I love that I get to focus on it because it was kind of the interesting pieces of all my jobs that I did before. So I get to focus on that now. So you can see, follow me at Big M Stone on Twitter, and we'll make sure that we get all the information out there that comes out over the next year. What about you, Matt?
Well, thank you for asking. Yeah, so I'm focusing on much of the same thing. A lot of network automation, network programmability. Working on a book with Scott Lowe and Jason Edelman. The three of us have already released the we'll call it the beta. It's being published by O'Reilly, and this is the early access copy. So you can basically see the first 5 chapters that we've written already. That's already out, and we expect to have the full book out by April, maybe May timeframe. The title of the book is Network Programmability and Automation. So just search for that and O'Reilly on Google. You can always follow me on Twitter as @Mearden. And then as we wrap up, thanks again to Madhu and Brent for joining. Again, Jen, it's always a pleasure, regardless of what you're working on. You can follow the ClassC Block at ClassC Block on Twitter, and then at ClassCblock.com as our website. We'll try to post as many shows as we can to that site as time goes on.
But no promises, guys.
No, there is no SLA here. Sorry.
All right, guys. Well, it's good to see y'all, and catch you on the next time.
All right, fellas.
Bye, guys.
See you later.